So I want to sketch the graph of the piecewise defined function. So the first thing you want to do, I always think when I look at these, you kind of want to start by thinking about sectioning the graph off into these three different pieces. And so I'll use kind of colors to show the three different parts of the graph. And so the first part is for x less than 0. So that would be this portion of the graph, right? So this portion of the graph is that. And then from 0 to 2 is going to be this portion of the graph. And then from greater than or equal to 2, so it'll be that portion of the graph. So we'll have three different things that we're graphing. So this first one is just a linear function, 2x plus 1. And so the y-intercept is 1 there. And then the slope is 2. So if I plug in like -1, say, I'll get 2 times -1 plus 1, which would be this point here. And I can keep going back with a slope of 2. So that part of the function looks like that. And then the middle part of the function is just a constant function at 3. So we'll go 1, 2, 3. It's an open circle there. So let me make that look really open. So it's an open circle there. And then since I still have a strictly less than at 2, it's still open there. So it looks like that. And then this part is -3x. And so it is again a line with a slope of -3. Let's figure out where it is when x equals 2. So if I do -3 times 2, that gives me -6. So the function at 2 is at -6. That's here with a slope of, and it's going to have a slope of -3. So if I go back 1, if I go forward 1, I'll go down 3. So it's going to look like that. And so that is our graph. So those three pieces. So I'm going to erase maybe these other little parts here that I had drawn on the graph. So you can see those aren't part of the graph there. They were just to help me. So those three pieces are my graph there. Okay, the next one, the graph of a piecewise defined function is shown. Find a formula for the function in the indicated form. So if I go here, so I guess we'll just call the function f, so we could call it whatever. So we'll call this guy fx. And I can see that it consists of two parts. The first part is this part here, and that looks like it's for x less than or equal to 1. And then the second part of my graph is this green part here, and that looks like it's for x strictly greater than 1. Okay, and that part is easy. It's just a constant function at -2. So we can write that part pretty easily. So it's just the function -2 for x less than 1 is that part. The other part here I'm going to need to figure out. So I have, it's a linear function, so I know it's going to be of the form like y equals mx plus b, right, or something like that. I need to find 2 points on my line. So I have the point 1, 4, and then it looks like the next time it goes through kind of an intersection there is at -3, 1. So I have the points 1, 4, and -3, 1. So I can use that to find the slope. So the slope is going to be the change in y over change in x. So I can do 4 minus 1 over 1 minus -3. And if I do that, I get 3 over 4 as my slope. So positive 3/4. And that makes sense because it looks like the rise is 3, the run is 4. So up 3 over 4. So that is my slope. Okay, and then to find the value of my intercept there, it looks like it's slightly over 3. It's going to be some fractional thing. So we can find that. So let's just plug in our y minus y1 equals m times x minus x1. And I'll just pick one of these points to be x1, y1. So I'll just pick the 1, 4, and I'll use the slope here for my m. So I can do y minus 4 equals 3/4 x minus 1, and then I can find it. So I get y equals 3/4 x minus 3/4 plus 4. So what is 4 plus 3/4? So that's 16/4 minus 3/4 is 13/4. So I get y equals 3/4 x plus 13/4. Okay, and so that goes here. So two ways I could have done that. I used the point slope form. You could have also plugged in these two things into this form, and you would have got the same answer. You would have got that b equals 13/4. So I'll put a comma here, so we separate those two things, and now we're done. The next one says a pizza restaurant charges $4 to deliver a pizza if the location is no more than 3 miles away, and they charge $1.50 for each additional mile, for a maximum distance of 10 miles away. For instance, for a location 4.6 miles away, they would charge $4 plus 1.5 times 1.6, which is $6.40. Now I want to write a piecewise function. Okay, so for the first 3 miles, they charge $4. So C is equal, so we'll say C of D maybe, or C of X. So my x-axis is labeled x. So C of x is equal to. So the first thing is if x is less than or equal to 3, it's just going to be $4. And then if x is greater than 3, it's going to be that $4 plus $1.50 times the number of additional miles. So it'll be $1.50. And you might be tempted to just put an x there, but it's not just x. It's going to be the amount that x is over 3. So we can do x minus 3. X minus 3 there. And so that is our function. Because it needs to be $1.50 times the number of miles that it is over 3. So if we subtract 3 off, we'll get how much it is over 3. Okay, and then I want to graph it. So for the first 3 miles, it's just going to be $4 straight. That's a straight line there. And then after that, it's going to go up by $1.50 for each additional mile. So at 4 miles, it's going to be $5.50. And at 5 miles, it's going to be $7. And so on. So we're just going to draw it kind of like that. So that may not be exactly the right slope, but yeah, you get the idea. What are the domain and range for this function? So the domain is all of the possible miles. So that's going to be from 0 miles to infinity miles, I guess. Maybe that's not totally realistic because, at some point they'd stop delivering, but, whatever. And then the range, for a maximum distance of 10. Okay, so sorry, never mind. I missed that in there. So yes, so that is a little bit realistic. So at some point they're going to actually stop delivering. So after 10 miles, they're like, nope, too far. So we're going to stop at 10. So we'll do on our domain, we'll stop at 10. Okay. Yeah, that makes sense. And then the range is going to be all the possible costs. And so we know the lowest cost is $4. And the highest cost, well, how much do they charge at 10 miles? So it's going to be $4 plus 1.5 times 10 minus 3, so 7 additional miles. So we can find out what that is. It's $14.50. And we'll put a closed bracket there because if they do deliver 10 miles, that would be the cost.